Welcome everyone, another video from Limitless Potential Technologies for you today. This is the series in which we are releasing new clean energy technology from here in my garage. If you're interested in science, dreaming big, tinkering, building things, just thinking differently and exploring all the possibilities in this world, you're in the right spot. That's what we're doing. We're bringing you along for every step of the process. My name is Spencer. I have a background in physics, applied sciences, engineering. Let's get into this. I want to show you what we've been up to. So in the past few videos, we've discussed what type of technology we're utilizing to get this clean energy. It's no different than solar power, wind power, hydroelectric dams. All of those systems are drawing from the environment, power from an open source in the environment, and we're doing the same thing here. It's just our source is slightly different. Our source is space or vacuum or quantum mechanical realm. So these devices are based off of this little guy over here, which is a Bini motor. There's two batteries. One runs the system, puts a pulse of energy into the coil, which causes this mechanical motion in the rotor. And then when the energy collapses out of the coil, we recycle it in the second battery. We use electronic switching in order to perform these pulses of in and out. And over here, we are doing the same thing. We've just got much bigger battery banks, much more advanced switches, bigger coils, more coils, higher frequencies, faster spinning wheels, larger weights in the wheel, bigger inertia. Everything's bigger and better in this system. So that's what we're doing. Let me show you this machine running. So the last time I left off, we had it on a power supply. Now we've stepped it up, so we've got one of the batteries running, one of the batteries charging. We're still just running it on a single 12-volt battery with a single coil, and I'll show you why here in a second. We are going to turn on our system. So we've got a nice kill switch. You can see all of our lights on our circuit board. On our first one are engaged. The lights for the DC to DC converters are engaged up there. Nothing's moving at this point. There's 8 little switches down here. You have to turn them on in order for the machine to work. Each one controls one of the coils or one of the circuitry. I'm gonna start spinning it first. You can see we've got our light flashing, indicating that this sensor here is allowing energy to flow. This sensor here is what controls the switches being on or off. I'm gonna give the machine a little spin, and then we're gonna go in and we are going to turn on one of the circuits. We have a single wire now powering this device. So one of the 8 coils, inside this coil there's 8 wires, so 8 coils. One of those coils is on. Now we're gonna turn on a second one. So we've got 2 coils on. I've gone through 4 of these optic sensors so far. We're burning them out. I'm gonna explain to you why we're burning them out here in a second. We've run into a little issue, and it basically I've got 3 coils on now, so we're gonna leave this machine running with 3 coils. It's running at about 70 RPM at the moment. It'll stay somewhere between 80 and 100 RPM, but that's the machine running. I am not going to run it any more than that at the moment. I don't know if you can see this scope here, but basically, see these little yellow spikes coming off the bottom of this? This is the DC power supply voltage. So this optic sensor takes 5 volts going into it. This is a constant 5 volts basically here, this line, but all of these spikes are, you know, upwards of 20 to 30 volt spikes. That's not good. Those spikes are happening because of the MOSFET switching, okay? So they switch so fast, and we have some of the circuitry within close proximity to one another, that there's a interference happening. And basically when I put too many circuits on, if I go up to 4 or 5 circuits, this optic sensor will burn out and a poof of smoke comes out. So we're going to fix that in the future. That's one of the first things we've encountered, but again, you're just learning. There's no such thing as failures unless you give up. It's only learning, right? Failures are good, they teach you. So anyways, this machine is looking quite fabulous. We're going to have 4 circuit boards mounted here very soon. I've wound more coils. You can see we have another coil ready to go here. I'm going to show you guys some footage of me winding the coils a little later at the end of the video. Seriously, I put in 10 hours of coil winding in the last 10 days here, so a lot of coil winding, but we've got everything needed to produce another six coils total, so we're going to get to that. But the battery banks are looking amazing. I went with solid copper bus bar to connect everything, just lower resistance, and it looks a lot better. And we're going to mount this clear acrylic just to cover it, so you kind of safes everything out, so you know we don't drop any tools and short out the battery banks. But overall, very happy with how it's looking. I'm excited, you guys. We're going to keep stepping it up. Higher voltages, higher spin rates. We've got the new circuitry coming for the timing wheel so that we can advance and retard the timing, modulate the input pulses. That's very critical. That's going to allow us to spin the thing up much higher and use as little energy out of the batteries as possible. I don't want to turn on another coil for you guys and show you this optic sensor blowing up, but let's run it for a little while longer. Okay, let's talk about wire sizing and the analogy between this and the flow of water in a river. Let's say this larger wire here is a larger river, a bigger channel, and then this narrow wire is a smaller river channel. So this smaller river channel would have more resistance to flow and water going through it than this bigger channel, okay? So that's what we've got here. We've got the large wire represented here by a big river channel, the small wire over here with a smaller river channel. The resistance of this small wire is much higher than the resistance of this big wire. The flow of this small wire is much lower than the flow in this big wire, and the pressure in this channel is going to be much higher than the pressure in this channel. Bigger flow, less pressure, less resistance than this one over here. Okay, so that's the difference between these two wires. If we have a load, such as this light bulb, it's rated in wattage. You can think of that as the total volume of fluid. It takes 60 watts or 60 units of volume. So say a bucket this size is going to be filled up with water in a certain amount of time, and that's your wattage or your power. This small wire over here, in order to fill up a bucket of the same volume as this river over here, this river is going to have a much higher pressure with the lower flow in order to fill up this bucket. So in order to fill up this 60-watt light bulb or bucket, we're going to have a much higher pressure over here than we are here. This one's just going to have a slower flowing river, but it's going to fill up the bucket in the same amount of time. So both of these wires can power a 60-watt load totally fine. They're going to fill it up in the same amount of time with the same amount of power or fluid. It's just one's going to have a higher pressure and one's going to have a lower flow. So that's our analogy for these wires. Now, what happens when we have another riverbed? So let's say there's another riverbed that's empty beside this one that's flowing, right? So let's say we have two conductors. This one's got flow through it, but this one doesn't. What happens then? Well, actually, the riverbed that's empty starts to get some water in it. It starts to get flow in it. There's a mutual inductance or spillover into the other conductor. So there's a spillover of energy into the riverbed that was empty beside the one that was flowing with water in it or energy in it. How does that spillover happen? They're not connected, right? They're separate riverbeds. How is water getting into that one? Well, it's because there's a huge amount of energy outside of the riverbed itself that's flowing. In fact, there's more energy outside of the riverbed or the conductor flowing outside of this conductor than there is inside of it, right? The energy that's powering the load, supposedly, is inside the conductor, but there's more energy outside of the conductor than inside it. So this energy outside of this riverbed spills over, and the water or the flow can be transformed into this other energy outside and vice versa. So that's just what I want to note on this analogy here, that these conductors have a huge amount of energy outside of the wire. And we talked about this last video with the old guys, Heaviside and Maxwell, explaining this, 150 years ago, 100 years ago, that they noticed there was way more energy flow outside of the conductors than inside of it. It's pretty crazy. They said all of this, like Maxwell, this old dude that gave us Maxwell's equations, he gave us like 20 equations before there was the electron or the atom. When he was describing electricity, electrodynamics, physics, he was describing it in terms of this fluid all around us. He called it an ether, vacuum energy. So vacuum energy and ether, they talked about that. They believed there was like a universal fluid that was everywhere, and this created and allowed electromagnetic waves to propagate, and they talked about electromagnetism and electrodynamics in terms of ether and vacuum. Then later on, at the turn of the last century, we discovered the electron and the atom. And they said, okay, there's no ether, there's no vacuum, waves self-propagate in space, forget all that. And then now we're getting into modern quantum mechanics farther down the timeline, and they're actually like, well, you know, there is vacuum energy, there is energy in space, vast amounts of it, but they're kind of kicking back to some of the theories that were originally thought of and how we thought about this. But anyways, it just goes to show that everything's changing. We're constantly updating, or we should be constantly updating all of our sciences. Again, where is the excess energy coming from for our system? It's not solar power, it's not tidal power, it's not hydroelectric dams. Where is this coming from? It's coming from the vacuum, the ether, all around us, quantum mechanical, whatever you want to call it. There's energy in space. Let's pretend that this energy in space is a river. So this river is vacuum or ether energy. It's all around us. You can call it an ocean or a river or whatever you want. Our current electrodynamics, or electron flow, particle physics, is based on a small portion of this river. So let's say it's a whirlpool. Okay, that's supposed to be a vortex within the river. Electron flow in our circuitry is describing this little vortex. So it's valid, but it's only a small component of what's actually going on. We negate the river, or the actual source of the energy that's creating this electron flow. How do we tap into this river? Well, we need to create an imbalance in the system. That's what we talked about last time, the last few videos, right? We talked about creating a dipole within the battery. If we create a dipole in the battery, because of the imbalance in ions, slower moving, heavier charges inside the battery, and then the electrons that we're putting in there because of the recycled energy coming in very fast, there's a difference in time and the amount of movement. They have to catch up to one another. So that difference in charge between the electrons and the ions creates a dipole, an imbalance, a sharp gradient. The sharper the gradient, the more energy that we can tap into from the river, right? So you create a sharper gradient. A gradient is a change, a rate of change. We can create a sharper gradient by upping the voltages, the frequency at which these spikes or these impulse functions happen. The more of these spikes that we can get into the river and allow the river to fix that imbalance, that's what the river wants to do. The vacuum energy is 4D, okay? This vortex is a 3D. The system that we're powering is 3D. So we're allowing the 4D vacuum energy to flow in, balance the system, okay? Re-gauge the system. It wants to do this naturally. This river is likely the cause of all power generation. We're likely utilizing the river for all of our current electronics and systems. We're just killing off the source dipole, the source imbalance where the river initially flows, through our modern understanding of electronics. We're incorrectly using it. Anyways, we'll save that for another discussion. But this 4D river flows into the 3D system. It wants to fix the imbalance caused by the dipole. Where's it flowing, you know? Well, again, the flow is outside of the system. You don't need to worry about the conductors or any of that, right? It's just like these conductors having a mutual inductance, the riverbeds, you know, spilling over into an empty riverbed just because it's flowing in the vicinity. That's the same kind of sort of thinking that we need to think about when we're talking about the vacuum energy flowing in. The vacuum energy is flowing into the electron flow. It's flowing into the ion flow. Is it flowing in as electrons? No, absolutely. It's flowing in as a different type of energy, okay? The electrons that power this load, this light bulb, the light bulb doesn't consume the electrons, okay? It consumes energy around the electrons, or at least that's what we're told right now. But again, the electrons have different energy levels, okay? So this vacuum energy can flow in from the vacuum from everywhere. It doesn't have to flow along the conductors. It's just flowing into the system, raising the energy in the ions and the electron. Then we can use that raised energy to do actual work within the system. So that's what we're doing here. We're going to measure the potential energy in the system before we start running it. So in the batteries, we're going to know how much potential energy, how many amp hours of potential energy we have in those batteries. We're going to do work with a wheel, with the rotor, and we're going to put a load on that wheel. So we're going to use a conventional generator to power a load, such as a light bulb or a resistor that we know the energy that it takes. Say those light bulbs or the load takes 100 watts of energy. Well, if we run the system for one day, 24 hours, that's 2.4 kilowatt hours of energy that we've used. So we know we've done that much work. If we run it for a week, that's going to be like 16, 17 kilowatt hours of work that we have done. So we will have a certain amount of work that we've done. We've got the potential energy of the batteries or the system that we started with, and then we can measure the potential energy after that period of time. That'll give us a definitive measurement of whether we have created Overunity, COP values greater than 1, a self-running system. It's not that hard, okay? We're not feeling that we've got Overunity. We're going to prove and test and show you that we do. So thank you all for contributing to this. This whole project has been made possible by 120 of you donating to the crowdfund. 3 of those donors paid for half of it, basically. We had some large donors, but 120 of you believed enough in us and our ability to put this money towards a scientific endeavor that is worthwhile, that you donated, and I appreciate it so much. Joe appreciates it, Kyle appreciates it, both of those guys, amazing, thank you both. We had our sponsor, JLC PCB, for the one video. They backed out, they bailed, they said they were getting hate mail from people, you know, people angry that they were being supportive of a free energy project, crowdfunding. They said they couldn't have their name attached to it, so we wish them the best. I still think they're an excellent company. You guys check them out, they're an amazing company. They just couldn't take the heat. YouTube doesn't give us any funding. It's crazy. They'll like give me my $50 or $100 a day that I'm getting from, you know, views, and then it's out of the account by the end of the day. So there's money in, money out. They literally cut off the funding. So we have no support other than you, no monetary support other than you guys. I am grateful to be on YouTube still. You know, it's a touchy subject, even though we're approaching it with a scientific mindset. It's just, you know, you can see the resistance to this in society. We've talked about that before. It's all about fear and people's mindsets. You know, they don't think that this is real science. So anyways, we're just telling you what's happened. We don't have any sponsors. We have no help from anyone other than you. You guys are helping us. So if you can contribute to this, the crowdfund is still up. I've got a Patreon link in the video, probably a coffee link, which is like Patreon. If you guys want to contribute a small amount on an ongoing basis, it means the world to us. Just that support, knowing you guys are there, is amazing. If you can't contribute monetarily, that's fine. Like, share, subscribe, that means the world to us. Definitely turn on your notifications, guys. Like, God only knows what's happening in behind the scenes on all this. Like I say, money comes in from YouTube and out on the same day. I don't know what that's about. I don't think we're getting any money from YouTube or anytime in the near future. I know part of that's being in Canada, but part of it's the sensitivity of the topics that we're discussing. So if you like real science and you want to support it, just continue watching, sharing, liking, subscribing. I'll try and get another video out, I swear to God, in less than 2 weeks' time. I know this one took 2 weeks' time. Moving forward, we've got some new bearings coming. My friend Mike, who's an amazing machinist, made me some aluminum spacers to preload the bearings once we get them into the machine. Right now I'm running Chinese bearings, ceramic bearings. They're all right. It's just they're not like fully sealed and lubricated. So I ordered some better ones. I think I spent $700 from a company, Ortec from California. They use Japanese steel or Japanese parts. They assemble everything in-house. So we got USA-made high-end bearings coming. They should be here next week. We're going to throw those into the machine. Then I'll be confident, you know, running this thing at really high speeds. It's a critical component, a lot of the stuff, right? You can't have it fail when it's just be detrimental. We don't want detrimental failures. So that's exciting. We're putting in new bearings. We've got more coils being produced. I'm going to show you guys some footage of the what it took to wind this coil over the last couple weeks. Basically, I spent like 10 hours. We ended up getting, you know, the pre-twisted wire, 8 strands onto these empty spools. And then from these empty spools, we feed it onto the lathe, which I'll show you here very shortly, winding it onto our 3D printed coils. Thank you, Kyle, for these coils. Joe, we love you. Thank you for the electronics, buddy. Amazing. I'd show you guys the motor running some more, but the optic sensor burned out in the time that I was talking here. So we got more optic sensors coming. We're fixing that optic sensor being blown out is, again, we're talking about the rivers spilling into empty riverbeds. That's what's happening with the circuitry. We're getting spillage from the switching of the FETs, and it's spilling over onto that little power supply that's feeding the 5 volts into the optic sensor, and it's overpowering it. So keep that in mind. Energy flows outside the conductors. We're talking about energy outside the wires, outside the system. It's all, it can flow. You can't see it. There's oceans of energy all around us, right? And we can tap into that with our technology. This is just one tiny piece. There's an infinite amount of technology that's been demonstrated over the last 100, 150 years. We just need to have an open mind and explore it in a scientific manner and demonstrate it and implement it without fear or greed. No patents, no greed. We're just getting it out to the people, and we have no fear, just faith. We know the end goal. We will never stop. There's only one end point, okay? It's success. We will never stop. Is there gonna be failures? Well, I don't know. They're not really failures. This is one of the coils I tried winding and it didn't work, but that's just learning. That was an hour and a half of my life. That happened twice. There was 3 hours just in trying to get the coil wound, me trying to twist 8 wires together, which is easier said than done. It's only a failure if you give up. Is the optic sensor burning out a failure? No, it's all learning, you guys. So never ever give up, okay? Just keep going. You know the end goal. The path will sort itself out. Just have faith, okay? Thank you all so much. I do want to mention there's still some sponsors. We got some sponsors. Finzri is a Chinese company that makes amazing electronics, power supplies, measuring equipment, very affordable. I've got all their multimeters and equipment. This is their multimeter, little handheld multimeter and oscilloscope. I think this one's under $200. They sent me this one. I love it. Really good quality stuff. So check out Finzri. I'll put their links in the description. And Vivor, which you'll see me using their lathe here. They sent us this metal lathe that was like $700. It allows us to wind the coils slightly. Probably cuts off 50% of the energy. My hands still hurt from my thumb being used so much to feed the wire, but much better. Thank you, Vivor. Thank you, Finzri, for not chickening out. They still support us. We're open to other sponsors, but again, you guys are what's really important. I want to make extremely high quality content for you. We're learning together. We're going to figure out the theory. You know, we can teach ourselves this stuff. It's not super complex. You don't have to make it overly complex, right? Science is for everyone, you guys. Once we get this running, then sure, people can write the complex math and figure out exactly what's happening. But overall, just keep it at a high level. And that's why science is wonderful, because there's always more for us to understand and explore and find in this world. We do not know very much. We have a limited knowledge. Don't ever think that you've reached, you know, a saturation point of knowledge in figuring out this natural world, because we haven't. It's going to be a long time before or if that ever happens. I think that's everything I wanted to say for today, you guys. Next video, 4 coils. 2 to 4 coils, higher voltages though. I want to have it up to 36 volts, 3 batteries. We're going to start spooling this thing up quick. We're going to get the new ceramic bearings from the USA in there. Shout out to the USA and the quality of material. I love China too. You guys have been great. It's just some of the stuff, like the wire from China is amazing. I'll show you guys some of the wire that we ordered. Picture of it. We got more wire coming. That's where your funds are going. We spent $4,000 on the batteries. We spent $5,000 on wire. Electrical components is like another $3,000. Joe's lab and my lab, we had to put another $2,000 worth of stuff into. The oscilloscope was $600. So thank you so much for making this a possibility. Thank you all. I love you all. There's limitless potential in all of us and all of our technologies. We just need the right mindset, no fear or greed. Okay guys, we're back in the field, back in the soccer field near my house. It's like 100 degrees out today, 40 something degrees Celsius, 100 Fahrenheit. I don't know what it is down there, you guys. I'm in metric, but it's hot. We gotta do at least 16 laps back and forth here. I'm gonna get at least 2 coils done today. So we're going 250 feet down that way. Let's get started. So back and forth we go. Originally, at the start of the day, I figured I'd, you know, spend a couple hours, get 16 or so, maybe 24 back and forth done, have 3 spools of wire perfectly completed in 2 or 3 hours. And yeah, that didn't happen. By the end of the day, I made a total of 60 to 70 trips back and forth, spent 5.5, 6 hours straight. It was nighttime by the time of finish, and this is just the first coil, and this one ended up getting thrown out. So a lot of learning. Basically, the majority of what I learned is that you need to just get those strands as tight as possible. They need to be exactly the same length, all very tight, close together, so when you start twisting them with the drill, there's no difference in the links, and there's no loops or little blips or crinks in them. It just will wreck the whole project. Okay, you guys, we got eight strands of wire out. It's so hot out, seriously, 100 degrees. Now I'm gonna make my little tower again here, just to keep the wire above the ground. Tower done. I got these empty spools here, these bobbins, so I can spool the wire on. Should make it much better. And then I'll go put these on the lathe and spool them off onto the actual coils. So let's take our tower halfway down, set up the tower. Now we've got our tower complete. We're moving down to the middle. We set it up, we put a towel on there just to make sure it doesn't rub through. None of the enamel coating on the wires. It's always a concern. Any rubbing through or continuity between the individual strands of wire is not desirable and will negate the whole build. So I'm cutting it off here and tying it up higher up on the fence. This is how I used to do it. I no longer do it this way, but used to do it this way. Now I just make sure they're as tight as possible on that crossbar and everything's equal lengths. We're back down at the far end, twisting the wire in the drill. You can see me down at the end here. That's 250 feet down. And we're getting everything twisted together. We've twisted it, now we're inspecting the line and we're finding that one of the wires was not as tight as the others, so it's creating little loops on the outside. You tell yourself that it's still gonna be okay, it's still usable, but I'm already realizing at this point that it's probably a write-off. Nevertheless, we're gonna practice spooling it up. So we're gonna tape it off at this end, put it in the drill, start spooling it up here. These spools are amazing. They just make it much quicker. After this one, I didn't have to put it in these side holes. I got it in a center hole figured out, so it wasn't so wobbly. But yeah, I see that it's kinked and it sets in that this one's... But yeah, I'm not quite happy with it. It's not a failure, it's just learning. It's part of the process. We're gonna keep going. I got another 4 hours of this for you guys today. Okay, you guys, we're back in the shop. It's been a long day. This is the final step of the process. We're gonna do one coil right now. We've got our lathe from Vivor. Amazing lathe, little mini lathe. It's gonna help us wind this, and we're gonna put on a glove. Technically, I shouldn't be wearing long sleeves with the lathe, but this thing barely moves, so we're pretty safe, and we got the shut off within reach. So initially, just to get the first few windings started, I just kind of do it by hand. Now we've got the lathe on, so you can see it just gives me a little bit of constant pressure. The oval shape definitely makes this harder than it would be, much harder than it would be with just a traditional round spool. Basically everything we've done here makes it more difficult. The twisted wire, octafuller winding, the oval shape leads to a more difficult wind, but that's okay because we're getting it figured out and we're making some pretty amazing coils here. There we go. Let's just feed that like that. Okay, there we go. Hand starts to jam up after a while. There's not really any way to automate that unless you make a whole apparatus to twist these wires. We finalized one coil that took about 25 minutes on the lathe, much better than an hour and a half by hand. So now I'm gonna get some epoxy on this guy, coat it in epoxy as quick as possible, let it set up, we got the tape secured there, but yeah, we're getting this technique down much better, you guys. So thank you so much for watching. If you're still here, unbelievable, to the bitter end. I love you guys. I'll see you soon. Another video coming up next, but that's 3 coils done. We're gonna have 6 very quickly. And yeah, let's get some epoxy on this guy. See you guys soon.